The first section in Chapter 5 is called the History of the Periodic Table. Here are some of the objectives that we're going to be taking a look at. Historically, we're going to look at what Mendeleev and Moseley did. Then we're going to describe the modern periodic table, and next we're going to take a look at how or explain how the periodic table can be used to predict the physical or chemical properties of elements. And finally, we're going to describe how elements in a group are related according to their atomic number. Okay, what we're going to be doing, again, this is just quick review. This video shouldn't take too long, but you started off in about 1869 with a Russian chemist by the name of Dmitry Mendeleev. He had about 60 elements that he was able to come into contact with, and he started to react them, and he knew that different masses were available as far as atomic mass. I'm sorry, the atomic mass, which is what we consider to be the mass number today, or it's synonymous, basically. He noticed that the patterns of the properties repeated. So what he did was he did a bunch of these he took a bunch of these chemicals, and he noticed that some were gases, he noticed that some were metals, and he noticed that some were nonmetals, and he arranged them by how they looked, the physical properties that they had, and he also arranged them on how they reacted with certain things. Like I always bring up the group 1 metals. He knew that when you took a pure sample of a group 1 metal and throw it in water, you end up with a good violent reaction. So he took all the nowadays the group 1 metals and he linked those all together. As a matter of fact, he was so good at this that he left empty spaces on the periodic table and said on his periodic table and said that these are elements that had not been discovered yet, such as like scandium, gallium, and germanium. Okay, so that's what Dmitry Mendeleev did in 1869. So we give him credit for that. Next, the problem with his tables was there was two problems, and the first is that he arranged his table by increasing atomic mass or increasing mass number. But some elements could not be arranged or were kind of out of place, which he noticed. One of these classic examples is element 52 and 53, tellurium and iodine. Now, tellurium, he had them switched, and he knew that iodine should probably be switched with tellurium, but he couldn't explain why that was the way it was. And the second reason is the second problem with his periodic table is he couldn't explain why the periodic table was periodic. So we have to fast forward about 40 years, and we end up with a gentleman by the name of Henry Moseley in about 1911, and he worked with Rutherford and found that the elements were better arranged by the number of protons, or the atomic number. So as far as the periodic table goes, they had the technology at the time in about 1911 to know that there was electrons, protons, and neutrons. See, back in Dmitry Mendeleev's time, he didn't have that kind of technology to determine what a proton was, what an electron was, what a neutron was. But now we know, and instead of organizing the periodic table by increasing mass number, they organized the table by increasing atomic number or increasing number of protons. Okay, now the element's physical and chemical properties were periodic. Tellurium and iodine were switched. Cobalt and nickel were switched. All the different little hiccups in the periodic table that Mendeleev couldn't describe were now fixed. And it turned out that the periodic table, or the elements, were periodic according to their atomic number. Okay? Now, so that means that we have now a periodic law. The chemical and physical properties of elements are dependent upon their atomic number. Okay, their atomic number. Now, if you take a look at the periodic table and the periodicity behind that, if you take a look at lithium and you count over, including lithium, and you count over how many elements do you have to count in order to get an element just like lithium, and the answer is 8. And if you have sodium, how many elements do you have to count to get an element that looks and acts and behaves just like sodium? The answer is 8. If you talk about potassium, it's 18. If you talk about rubidium, it's 18. And if we actually went one more step, we'd have 32. So the periodic table has a periodicity. It's not a periodicity that we're used to, but it's a periodical type thing where it goes 8, 8, 18, 18, 32. Okay, to be more specific, you can probably say 2, 8, 8, 18, 18, 32. So that's the modern periodic table. Our modern periodic table is arranged by increasing atomic number, or the number of protons. It turns out that periodicity is dependent upon this atomic number, and there is a periodicity which has the pattern of 8, 8, 18, 18, 32. Okay? Let's see, is that it for this slide? Oh, we got some review, and I believe that does it. Okay, so that's the end of the first section, and look for future videos for more sections.